In this video, we'll learn about methods of separating matter. So to start, let's talk about mixtures and pure substances. Two pure substances, like for example, salt and baking soda, could be physically put together into a mixture, but the mixture can be separated back into its original components using physical processes. Now, substances in mixtures, really important thing is that they retain the properties that they had as separate pure substances. And differences in the properties of these substances can be used to separate a mixture into its different components. For example, filtration. Filtration is used to separate a mixture based on either the size of the particles within it or the phase of matter. So in our diagram to the right here, we have an example of a solid and a liquid in a mixture. Um, they are being poured over a piece of filter paper, and the filter paper is allowing the liquid to go through, but the solid particles end up trapped on the filter paper. And so we end up with whatever the pure liquid is and the pure solid being separate from one another. And that's all based on the fact that the liquid can go through the filter paper and the solid cannot. That is a physical separation. Additionally, there's a possibility of distillation, which separates mixtures based on their boiling point. So if we had, for example, alcohol and water mixed together, they would not be separable by filtration because they're both liquids. However, they boil at different temperatures. So if we had a mixture of alcohol and water in a flask right here, we could heat it, and at one temperature, the alcohol will boil off, and the gas will be caught in this condenser. And this condenser, you can see there's like an inner tube here. That's where the gas is going through. But surrounding that inner tube is an outer tube that has water in it that's cooling down the vapor as it's going through the tube, causing the alcohol to condense into the liquid phase. And it just travels down and drips into another beaker here. So with heat, you cause the alcohol to go up and over, and then finally to drip down, and you get alcohol here, and water remains behind. Because the water will boil at about 100 degrees Celsius and the alcohol somewhere in the 70s. Next is chromatography, which separates mixtures based on their polarity. Now, polarity is something that we'll cover later in this course, but you may understand the concept of hydrophilicity and hydrophobicity. So, if something is hydrophilic, it likes water. If something is hydrophobic, it does not like water. An example of something that's hydrophobic would be oil, and you know that oil and water do not mix well. But water mixes well with a lot of other things that are hydrophilic, like for example, alcohol and salt. Um, Now, with chromatography, you may have seen this in a biology lab, that if you put a pigment onto a piece of paper and allow a solvent like water, for example, to climb up the paper, the pigments that have more of an affinity for the water will travel up further with the water, and those that don't have as much of an affinity for the water will not. So the hydrophilic molecules go up, the hydrophobic don't move very much. And based on this, we can see that from this initial mixture of many substances, we get carotene moving the furthest. It is the most hydrophilic, and then xanthophyll is the next, and then chlorophylls A and B in that order. This concept can also be applied to what's called a column. And in column chromatography, you can just basically flush a solvent like water through a column continually. And what starts off as a mixture starts to separate, that we can see here, and it separates further and further and further. And in this case, the blue component of the mixture, that comes out first. And once all the blue is gone, you can swap out the beaker, and then the next substance comes out. which is apparently pink. And so that comes out, and you swap out the beaker again before flushing out all of the yellow component. Now, there are other types of techniques for separation. One is decantation, so just to decant. Um, this is where there might be a heavy sediment, a solid, mixed in with the liquid. You can just pour off the liquid. Now, that doesn't get rid of all the liquid, but it can separate out all the solid. Also, magnetism can be used if you have two substances that are mixed together, like sulfur and iron. Of course, a magnet will do very well to remove the iron from the sulfur, and that's one way to separate a mixture that has a magnetic component and a non-magnetic component. Now, those were all physical techniques of separation, and they separate mixtures. But to separate compounds is a different story, because elements that are within a compound, they are chemically bonded together, and so you can't simply use different physical properties to cause separation. Sodium chloride, for example, chlorine is a gas, sodium is a solid, but sodium chloride is a solid and it's all consistent throughout. You can't simply allow the chloride to evaporate off, and that would separate them. Separation can only occur among compounds through chemical processes, through chemical change. And the way to separate a compound into its different elements is through decomposition. A classic form of decomposition is known as electrolysis. And here is a bit of a diagram for it. We have some water, and the water being formed of hydrogen and oxygen, it will be separated into hydrogen gas and oxygen gas using a battery. What happens is the battery applies energy, electrical current and energy, and that electrical current and energy goes towards breaking the bonds between hydrogen and oxygen, and you end up getting hydrogen gas at one electrode and oxygen gas at the other. That's something to study more in depth in an electrochemistry unit, but for now, the electrolysis process is a way to separate compounds into their component elements. Hope this video has helped. Please feel free to leave any comments in the comment section below. Thank you.